practice some general chemistry. In this problem, we will balance a chemical equation, use stoichiometry to determine the theoretical yield and limiting reactant of a reaction, and using theoretical and actual data, we will find the percent yield. Let's start by balancing the chemical equation. On the left side, we have phosphorus, oxygen, and hydrogen, and the same is true for the product side of the reaction. On the reactant side, we have 4 atoms of phosphorus, 10 plus 1 of oxygen, which gives us 11, and 2 atoms of hydrogen. On the right side of the equation, we have 1 atom of phosphorus, 4 atoms of oxygen, and 3 of hydrogen. So let's start by balancing our phosphorus atoms. So we can add a coefficient of 4 to the right side of the equation, and that will give us our desired 4 atoms of phosphorus. And then that leaves us with 16 atoms of oxygen and 12 of hydrogen. So where do we go next? Should we balance our oxygen or hydrogen atoms? If we look at the left side of the equation, oxygen is present in both reactants, but hydrogen is only present in one. So let's start there. So on the right side, we have 12 atoms of hydrogen. So we can achieve that by having a coefficient of 6, which gives us our 12 atoms of hydrogen. And then instead of having 1 atom of oxygen on the right reactant, we have 6. And so now 10 plus 6 gives us our 16, and we are fully balanced. So now let's move on to our stoichiometry calculation. We're starting with 2.75 grams of P4O10. We now need to convert from grams of P4O10 to moles of P4O10. And we can do that using the calculation for molar mass using the periodic table data. So we have the molar mass of P4O10. We have 30.97 for the molar mass of phosphorus. Then we can add the molar mass of oxygen, and that gives us 283.78 grams per mole. So we can add that into our calculation. Grams per 1 mole. Now we can use our balanced equation to do the mole ratio. So for every 1 mole of P4O10, we have 4 moles of H3PO4. And now we can convert from moles of H3PO4 to grams of H3PO4. And again, we will use the molar mass of H3PO4. So here we have our mass of hydrogen plus our mass of phosphorus plus our mass of oxygen. And that leaves us with 97.93 grams per mole. So 97.93 grams per mole. But what are we asked for in this problem? We're asked for milligrams. So let's convert from 1 gram to 1,000 milligrams. So now our calculation stoichiometry setup is complete, and we can calculate out to give us 3,796.0 milligrams. But let's pay special attention to our significant figures. So given in the problem, we know we have 3 sig figs. So let's use scientific notation to help us. So we have 3.80 times 10 to the 3 milligrams. And that is our final answer for part A. Now we can determine the limiting reactant. So we know based on this value how much H3PO4 we can achieve from 2.75 grams of the P4O10. But now it's telling us that we're using 3.0 grams of water. So what yield does that give us? So we'll start with the 3.0 grams of H2O. And we need to go from grams of water to moles. And so the molar mass of water, which we can probably do in our head, but we have the 1 gram for the 2 hydrogen atoms and then the 15.99, which gives us 17.99 grams per mole. And that was just 1 atom of oxygen. So 17.99 grams per mole. Now we can look at the equation for our mole ratio. We're going from 6 moles of water to 4 moles of H3PO4. Now using the same conversion factor from the previous equation, we're going from 1 mole of H3PO4 to 97.93 grams of H3PO4. And for the sake of comparison, let's convert also to milligrams like we did above. So in every 1 gram, we have 1,000 milligrams. And this calculates out to give us 10,881.1 milligrams. And to get us to our correct number of significant figures, that puts us at 10.9 times 10 to the 4th milligrams. So that's our final answer for that yield. And we see that this value is larger, so this will be in excess. So that tells us that for our theoretical yield, we are going to have 3.80 times 10 to the 3rd milligrams, or 3.80 grams of H3PO4. So our limiting reactant in this case is the P4O10. And this is the value we're going to carry down to part C. So let's recall that the formula for percent yield is actual value over theoretical value times 100. So for this case, our percent yield, we're given the experimental value, so that's the actual value of 3.5 grams H3PO4. And we know our theoretical value above is 3.80 grams H3PO4 times 100 gives us 92.1%, but part C gives us only 2 sig figs. So let's report this as 92%. And there you go.